The crank and connecting rod of a theoretical steam engine are 0.5 meter and 2 meter long respectively. The crank makes 180 rpm in the clockwise direction when it has turned 45 degree from the inner dead center position. Determine the velocity of piston, angular velocity of connecting rod, velocity of point E on the connecting rod, 1.5 meter from the gudgeon pin, velocities of rubbing at the pins of the crankshaft, crank and crosshead when the diameters of their pins are 50 mm, 60 mm and 30 mm respectively, position and linear velocity of any point G on the connecting rod which has the least velocity relative to the crankshaft. Now from the given problem we can write down the given data. So NBO, which is a revolution of crank, which is equal to 180 rpm, that is given in clockwise direction, from which we can calculate angular velocity omega BO, that is 18.852. Since the crank length OB equal to 0.5 meter, therefore linear velocity of B with respect to O, or velocity of point O, because O is fixed point, VBO is equal to VB is equal to omega BO into omega B into 18.852 into 0.5 to 9.42 perpendicular to BO. Now with the scale we can draw the space diagram as per the given dimensions. Here OB is the crank, PB is the connecting rod. We can start the space diagram by selecting the point O, that is starting point. OB crank, PB connecting rod, point E on connecting rod PB. Okay, so this is velocity diagram of the given space diagram. First locate the any point O as pole point. Now draw vector OB as per scale. You will get the point B and the direction will be towards B. Then draw a perpendicular line to link PB, and then draw the another vector OP which is parallel to the path of slider. Both the lines will intersect at point P. In this way we can complete the velocity diagram. We can locate the point E as per the position of point capital E on the link PB by dividing ratio. Now on space diagram you can see the point E is shown and point G also shown. So we can locate the point E and G on vector PB. Then draw join point O and E. Similarly point OG you can join and show the direction. In this way, this is the velocity diagram of the given space diagram. Now we can arrange the velocity diagram on the space diagram also. Now in this way we can arrange the velocity diagram on space diagram. This is what velocity diagram. This is for understanding purpose. Now you can see that vector OB is exactly perpendicular to link OB. Similarly, vector PB is also perpendicular to link PB. Now here you can see that the vector OB is exactly perpendicular to link OB, which is rotating in clockwise direction. Linear velocity of point B also shown. So we have to draw the vector OB in the direction of velocity. Okay, you see that both lines are perpendicular. Similarly, we can draw the vector BP perpendicular to link PB also. Now this is path of slider. PO is along line PO. We can draw the vector OP parallel to the path of slider and show the direction. So in this way we can arrange the velocity diagram on space diagram itself. So now I am going to tell you about the table. In table, each and every parameter you can show, you can study there. Here the link BOPP shown, their lengths are shown 0.5 meter and 2 meter. The linear velocities of total links, number of links are there, from which we have written the all linear velocities. Now from which we can obtain the vector also. ABO means OB, VPB means BP, VPO means OP vector. In next column it is shown that how to draw the velocity diagram by drawing a vector OB perpendicular to link BO. Then draw vector BP perpendicular to link PB. Similarly, draw a vector OP parallel to the link PO, that is parallel to the velocity of slider path. Now in this column we can calculate the linear velocities by multiplying the scale. In last column it is shown that we can calculate the angular velocity also by using relation omega is equal to V by R.